Hi guys, welcome to Learn with W3 Schools, and continuing from last session, today we're going to continue our programming tutorial and we're going to discuss few more topics. Now, if you have been following me, we have started this R programming tutorial series using W3 Schools website as a reference material. We have already discussed about the basics of R, why is it important. We have gone through syntax, comments and variables. Today, in this session, we're going to talk more about the data types, numbers and maths. Okay, so before we go further, please, if you still haven't subscribed, do subscribe, hit that bell icon so you can follow the series regularly and get the notification for it. So without further ado, let's begin. So what exactly are data types? Now in programming, data types are quite important. Basically, data types define us that what type of data we are using in terms of whether it's an integer number, whether it's a string, or whether it's a character, or whether it's a decimal number called float or double. So it defines the system, it tells our memory and processor that what type of data we are actually operating on. So that's what basically the concept of data types comes into play. Variables can store data of different types. So whenever we have declared variables previously, they can store actually multiple types of data. In different types, you can do different things. Every data type has its own specifications and operations that you can do on them or cannot do on them. Okay. So in R, variables do not need to be declared explicitly. In our programming language, you can declare a variable, but usually you don't need to do that explicitly. You just decline a variable and assign a value to it. Based on what value you assign, it automatically gives them the data type implicitly. Okay, but you can do this explicitly as well. Okay, so we have already seen that. Okay, this is a variable. We use an arrow and then we define the data. So what this basically means that it automatically will go and say, hey, I'm going to use 30 as an integer number, and this variable becomes of type integer. Or if you define a string within inverted quotations, this will become a string character and will be automatically assigned to the string. So implicitly, it will automatically know what type of data you are working on. R has a variety of data types and object classes. You will learn much more about this as you continue to grow about R and as we cover more topics in detail in next sessions. But the basic type of data, let's cover them quickly. What exactly are those basic types of data? So in R, we have something called a numeric data type, which basically means number form. We have integer data types, which are basically simple integer numbers. We have complex data types, i.e. that have a complex notations with them. We have a character data type, i.e. a string. In more commonly, we call them in other programming language string, but in R, we specifically refer to them as characters. And then we have a logical data types, i.e. known as Boolean data types. Okay, so these are basic types of data that we use within R. For example, if you come here and you declare a variable as 10.5, this is known as a numeric data type. In typical languages, we call them float or double. 10.5 is containing a decimal value, again is known as a numeric value. Similarly, an integer basically means an integer data type and it precedes with an L. L is just as an indicator, it precedes that indicates that, hey, I'm using an integer type of data. Not compulsory, but it's usually written there. So if in previous example, you've seen that we did not write L, still it's considered as an integer number. Then we can use complex numbers that uses, for example, 9i plus 3. This becomes a complex notation. So I power to 3. Then we have character or a string data type that is usually inside an inverted quotation marks. For example, R is exciting. Yes, it is. And then it uses this string data type to be assigned automatically to this variable. And then we can have a logical, or in a common term known as Boolean data types, means you write true or false. This is only a type of data that contains two values only, either true or false. That's it. Okay. And then we use a class function to determine which type of data it is. So if you execute the code, you will notice that it gives us the type of data we are using. So the class function actually here is defining us that what type of data we are using. So in other words, we try to find out that, hey, I have a data, I don't know what type it is. So you use a class function, it tells you, okay, this is the type of data you are basically using. And it will give us a response, whether it's a numeric, integer, complex number, character, or a logical word. Okay, make sense? Wonderful. Huh? Let's go further. So you will learn much more about these individual types in upcoming chapters though as well. Let's learn about numbers now. Well, our numbers are simply numbers, right? But there are three types within these numbers. Means that we have a numeric type, which is again the decimal value. We have an integer number, which basically means any whole number. And then we have a complex number, which again means you use complex notations like I power to e, or I power to 1, or e power to x, or so on and so forth. Exponential notations, as we sometimes call them in mathematics. So variable numbers of types are created using value you assign them to them. So basically whatever value you assign them, its number is implicitly automatically assigned to it. So we have 10L, which basically defines as an integer number. If you use points or decimal values, it becomes a numeric. And if you use I notation, it becomes a complex number. A numeric data type is the most common type of in R. It contains any number with or without decimal value, like 10.5, 55, 706, all of them are considered as numbers. So for example, when you use 10.5, still a numeric value. You use 55, still a numeric value. So when you print the values of X and Y, it prints the value, whatever has been stored in those variables. And remember, we have already talked about it. You can use X or Y directly, it will print the value, or you can put them inside print method. To find out what type of data is in this XY, we use the class function. Then we have integer type. Integer type are specifically a numeric data without any decimal numbers. So this is used when you want a certain value that will never be used as a decimal point. Okay, so to create an integer variable, you just have to use this L symbol as a postfix. So at the end, as a postfix, you basically use this L symbol indicating that this is an integer number which will be assigned to this X. Hence, it will explicitly know, I'm creating an integer number though. So whatever number you're using, just preceded with its capital L, it becomes an integer number, and then you can print it out. If you execute the code, you will see that first, if I use X and Y, it prints the value without the L. So do keep in mind the L is just an indicator telling the R compiler that I'm using an integer number. As an output, this L doesn't get printed at all. So you don't have to worry about that, how to remove the L in the output. So when you print the output, it just prints the integer number. Then you can use the class function to determine what type of data it is, and it will tell you, hey, these are integer number because we have used L here explicitly. Make sense? But let's go forward. So now, if you use complex numbers, well, complex numbers is written within I as an imaginary part. Okay, so we write X with the arrow function 3 plus 5i. I becomes the complex number imaginary notation, or you can just simply write 5i as well. When you print the value, it prints the value, and you can find the class, using the class, you can find the data type as well. So here you go. So now check out the output of this thing. When you use X and Y to print the complex number, it prints the complex number as it is, 3 plus 5 to I. If you use just 5i, it will again use 0 plus. So it will precede or do this prefix as well, because again, the notation has to be on the power 5i. So that's why this imaginary number is printed with 0 plus 5i. So always keep in mind this thing as well. This can get sometimes a little tricky. When you use 5i, it basically will use 0 plus 5i as a notation. If you use the number here as a denominator, then it works fine for this. So X plus Y, X comma Y, you print the values, it prints the output. You use the class function to determine the type of the data it is. Okay, the type conversion. Now, here's the tricky part here. Sometimes you use or declare a data, and then you need to convert one type of data into another. By that, we mean that, for example, you declare a variable as a numeric, but then you want to change it to an integer number, or a complex number into an integer number, or an integer number to complex, vice versa as they go. To do that, we basically use certain functions, such as these ones given. Here, we are using function as.numeric to convert data from integer to numeric data type. We can use integer value, which will basically convert any numeric into a type integer, or you can use complex, which will convert any number into a complex form. How do we do that? Let's see an example with it. So here you can notice the example. We have X, we declare a variable with 1L, which becomes obviously an integer number. Then we have Y, which is a numeric value. When you convert this from integer to numeric, we use A as a resultant variable. So the answer is actually saved inside this variable. We use as.numeric, and then we pass it the value of X as an argument. What happening now is that it takes this integer number, processes it, and then returns a numeric value and assigns it answer to this numeric variable. So this behaves as a function. Okay, inside this AS class, we have a numeric function. This numeric function will basically convert, or what we call cast, X into A. Similarly, we have AS integer. What this is going to do is, it's going to take this Y variable, which is again a numeric variable, and then it's going to convert this numeric value Y using this as.integer function and assign the answer to the B. Hence, if you check the value of A and B, it's going to return the resultant value, which is again numeric and integer. So as you can see, now we have numeric and integer. So initially we declared them as integer and numeric, but then using these functions, we can convert any type of data using as object.numeric, its function, and then we pass it a value in terms of an argument. What this is doing again is converting the data from one type to another. This is called what we call a type conversion. Okay, make sense? Let's talk about math now. In R, you can use operators to perform common mathematical operations. Okay, and then obviously this is the major purpose. We use R for data science and analytics and everything. So math operations are quite commonly used. So one common operation you already know, I think from class 1, plus operator. It's obviously going to do 5 plus 10 and add them together or subtract them together. And then there are various different built-in functions as well. Obviously, you can use all mathematical signs, plus, minus, divide, modulus, remainder operators in ease. Okay, built-in functions basically perform certain calculations on them. So, for example, we have a maximum function and a minimum function. What they're doing is it's determining, if a max function is used, it determines amongst the number or the list of numbers that you have provided, which value is the maximum. Okay, so which value among these three is the maximum. Similarly, if you use the minimum function, it's going to determine that amongst these three values, which value is the minimum one that we are supposed to use. Okay, if you check the code, you would find that it returns the maximum number for the max function and the minimum value from the minimum function. So using functions, we can determine some things as well in mathematics, or in using R, using some mathematics. Similar to minimum max, there are tons of other methods that you can use. Some of them are, for example, SQRT. Makes sense, right? It finds the square root of a number. So whatever a number or a variable you pass it here, it will determine the square root and return the answer. The ABS function returns an absolute positive value of a number. So if you use a minus sign, it's going to return an absolute positive value. You can use value functions called ceiling and floor. These functions rounds a number upwards to the nearest integer, or the floor function rounds the number to the nearest lowest integer. Okay, so for example, if I use ceiling 1.4, it's going to round it off to the upward nearest value, and then similarly floor will give us the lowest value. So when you round it off, 1.4 now becomes, the highest value becomes 2 because it rounds up upwards to its ceiling, and the floor subsequently will does the reverse and it rounds down to its lowest value. So it becomes 1.4. Oh, sorry, just 1.4 becomes simple 1 value. Okay, so whenever we need to do rounding off to an upper or lower values, we basically use ceiling function and floor function. They just handle the entire rounding off automatically. Similarly, there are many other functions that you can use. If you just check out the ceiling R's basic tutorials and reference lists provided at the bottom, you can find many data and values here. Okay, let's talk about strings now. Well, a string are used to store text. So anything you write inside inverted quotations will basically work. In R, you can use double quotation as well as a single quotation marks to indicate a string value. So for example, when you use double quotations, it's also legit, also allowed, or you can use a single quotations as well. Works perfectly fine. They basically mean the same thing, that we are using a string literal. How do we assign a string to a variable? Again, we have seen that example. We have to declare a variable, use an arrow or less than sign minus, and then we assign it a string. Then you print a string variable, it prints the entire string to us without the inverted quotation marks. You can use multi-line string as well. To do that, well, we just simply start with an inverted quotations, write the multiple lines of code, close the inverted quotations. And when you print the value, it prints the whole string, not just the first line, it prints the whole thing. Yep, so you can see this, now it has the entire string. The only key thing is that it prints in one single line, and it adds this \n here in the output. Where did this come from? This came from here. So when you moved \n here, pressed enter, it will save this enter as a character. So that character has a symbol called \n, which technically is known as escape character, and it will just print out this symbol on the output itself. So beware of this. Okay. Then, however, note that R will add the \n at the end of each line. This is called escape character, and the n character indicates that it's a new line. If you want to break the line manually, instead, so what we do is we use this cat function. Okay, so what now it's going to do is it's going to use this \n and automatically insert the new line. So if you execute the code, bada boom, now you see that all the text is in a much better way. So the previous answer, when we just use the string, it's going to print the whole string together. So instead of adding that new line, it printed a symbol called \n. So it just confuses a little bit that why is this a backslash n, because this backslash n indicates a new line, and new line has this backslash n hidden character. Okay, so if you want to print it as a normal thing, you use this cat function. The cat will automatically read the new line and add an actual new line in your output. Okay, so this cat function does this thing for you. So it will read the new line backslash n and actually add a new line and remove this backslash n from your output. Hence, you get exactly what you write. Okay, so the output is in much cleaner form. So whenever you need to use a multi-line content or multi-line text in your output, make sure you use this cat function. Then we have some other built-in functions that we can use with the string, such as length. The length function will calculate and count the number of characters in your string. So it depends on how big your string is. It will automatically go and count each single one character and return to us the total number of characters in your string. See, so this is returning 12 to us. So we use this n character function. So it will calculate the length of this string or the number of characters in the string. So n for number of characters, a function built in. You pass it str as an argument inside the round brackets. What it's doing now is it's calculating each one character, counting one of them, each one, including the space. Do mind that space is a character without any physical representation. So we have a space as a character. This will also be counted, and then the rest of the words. Okay, so n character, very cool function that allows us to calculate the number of characters in a string. Then we can use another function called grepl. Grepl function is used to check if a character or a sequence of characters are present in a string or not. In other words, it is used to find or search something from your string. So whenever you need to search something from your string, you use this grepl function. What it is doing is, for example, we have a string called hello world. We use grepl function. We provide the character h, which is the indication that I want to find the index of this basic number. I want to know whether this h, capital H, exists in this string or not. So we use h, comma, string. So now it's taking two arguments. The first argument is the string that we want to search, comma, and then the string from which we want to be searched from. So in this case, the str variable. So we pass it the str variable, we give it a string, and then it finds the string. So if I execute the code, you will find that it returns true, 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 or false, indicating that whether this h exists in this string or not. If it does, it returns true. If it doesn't, it returns false. So in this case, grepl uses x. Is x present? So obviously it's not. So it returns false for us. So using grepl, we can very easily do a small searching to determine whether a sequence of characters or a single character exists in any given character or not. Similarly, we have a function called paste. What paste is doing, it is allowing us to merge or concatenate two different strings together, forming one single string. To do that, we have a string called str1 hello, and we have another string called string2 the world. Right? So we use a paste function, and it copies and pastes both strings together in one single string form. So if you execute the code, the output would be basically two strings combined together. We get hello world. Okay, so the hello world became possible because we used the paste function to combine two strings together. Make sense? A little bit, right? Yeah. So this becomes few step. So this is few functions that we can use with the strings. Again, you can check the reference library and find out many other functions that are available for the strings as well. Let's talk about Booleans now a little bit. All right, Boolean or logical values. Okay, so Boolean basically determines us that whether the value is true or false. So you often need to know if an expression there is either true and false. Even though if, for example, in this case, when we return the true and false, so this true is actually a value that was returned from this grepl function. So the system or the processor needs to know what type of answer I got. The answer either in this case is true or false. So this is also a type of data. A data that holds either true or false. So even the processor needs to know that what type of answer we are getting. So that's why we use Boolean, and it's very important, very useful. So you can evaluate any expression in R and it gives us answer in form of true and false. But expression evaluation means just like we did here, we asked grepl function to find out whether this string exists or not. If it does, it returns true. This true is of type Boolean. Or we will use this same thing within operators, if else, while loops, for loops as well. So they all use expressions to determine few things. Based on those expressions, they make a decision. So those expressions need to be in form of either true or false. Okay. So for example, we have examples of few expressions written here. What we have now is 10 greater than 9? Okay, so this is a greater than symbol, arrow indicating that the value on left hand side is bigger than the value on the right hand side. So it's determining if this is true or false. This is called a logical expression. So since 10 is bigger than 9, the answer would be true. Similarly, we can write double equal to sign. The single equal to assigns a value, but the double equal to operator does a comparison. It says, is the value of 10 equal to the value on the right hand side, which is 9? This will return false for us because again, they are not equal. Again, do remember you can use values or variables for that matter as well. So you can compare two variables as well. Similarly, we have 10 less than 9. Again, the value is false because 10 is bigger. So the less than will be that the value on the left hand side is less than the value on the right hand side. If you execute the code, you would get the similar output. See, true, false, false. Okay, so 10 is bigger than 9, we got true. 10 equals to 9, we got false. 10 less than 9, again equals to false. So you can use comparing two variables value as well. So for example, I have a variable a containing the numeric 10. I have a variable value b containing the numeric value 9. So I can use if a is bigger than b. So you can easily compare variables, values as well. You can also run a condition in an if statement, which will basically we will learn later on, but this if condition is used for comparison. It determines that whether value is true or false. Based on that, it makes a decision which line of code to execute. So it creates that non-linear diversion within your code. Okay, so here, for example, we have two variables value called 233. So we check whether if the value of b is greater than a. If it returns true, the if block will execute. If it returns false, the else block will execute. That way, we can control which type of data is executing. Make sense? But more about this in if else as well. So the only thing to keep in mind is this Boolean thing. Okay, wonderful. So now this concludes today's session. Next, we're going to go into operators, if else, while, and loops. So the next session is going to be very much interesting. So do tune in, keep watching, do subscribe if you still haven't done so that you can follow along our programming tutorial with me. This is Dr. Dishan from Learning with W3 Schools, signing off.